Alright, so we have a powers question. This first one is also in a fraction, so we'll need to use our power rules to simplify this. And the question also does specify leaving it with a positive indices, so we'll make sure we convert that -1 to a positive number somehow. So let's tackle the numerator first. Notice we have these brackets here, all raised to a power. So to simplify that, we will distribute the power. I'll just do a simpler example first. So 3 times 2, all to the power of 2. Now if I ask you what does this evaluate to, you might just use your bid maths, right? 3 times 2 is 6. Now we're left with 6 squared, which is 6 times 6, which gives us 36, which is correct. Another way we could approach this is using the power rules. So whenever we just have a number or a variable with no power written up there, it's actually implied to be 1. And now this was all raised to the power of 2. Now we can distribute this power of 2 across each of these powers. So to distribute a power raised to another power, we multiply. So we're left with 3 to the power of 1 times 2, which is just 2, multiplied by 2 to the power of 1 times 2, which is also just 2. And now, using our bid maths, 3 squared is 9, times 2 squared is 4, 9 times 4 is 36. So these are two equivalent methods of simplifying this problem. Alright, and we're going to use that method on the right, powers of power, to simplify the numerator. So we have 3y all to the power of 4. Now we can distribute that as 3 to the power of 4 times y to the power of 4. Awesome. And now let's just keep the denominator the same. Now 3 to the power of 4, 3 times 3 times 3 times 3, which is 81. You can use your calculator to check. Everything else stays the same. Now we can simplify the coefficients. So 81 divided by 3 is 27. And now just looking at the variables, the powers. When we divide powers, we subtract the power in the denominator from the numerator. So in this case, it would be the numerator's power, which is 4, minus the denominator's power, which is -1. Notice how I use brackets there, just to make sure I'm aware of the subtracting a negative, which gives us 27 times y to the power of 5. Alright, and part 2. Notice we have this cube root, or this root symbol, and the question specified positive indices, okay? So right now, we could, instead of expressing it as a root, we could do it as a fractional power. So for example, the square root of x is the same as x to the power of 1 over 2. So 2 is the nth root, so in this case it's a square root, and then the 1 in the numerator corresponds to the power of the variable. Another example, maybe a to the power of 3, then the 4th root. So we'd have a to the power of 3 over 4. So over here, we can distribute this, so we'd have 8 to the power of a third times y 27 all to the power of a third. And now 8 to the power of a third, you can just cube root 8 or do it on your calculator. We get 2. And now y to the 27 to the power of a third is y to the 27 over 3, which simplifies to y to the power 2 times y to the power of 9.